In today's tutorial, we'll build a scene with intersecting groups of concentric rings. The focus here is going to be on building the scene, so we aren't going to go into all the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.31, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. First, we'll set up the renderer. Open the palette with the Alt-R shortcut and create a RayMarch Render 3D. And then create a null top connected to the first output so you can see the image that it produces. I'm going to set the resolution so it fits in the side panel, but you don't need to do that. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, we're going to choose Look at Camera. On the camera, we're going to set the FOV angle to 70. And then leave the other settings on the defaults. Select the renderer again and open the editor tools with Alt-Shift-R, and then under Add Light, we're going to choose Point Light. And on the light, we're going to set the position to 484. Next, we'll create the SDF that will define the shapes for our scene. Open the palette and create a rings SDF. And we're going to connect that to the first input on the renderer. This operator produces an infinite series of concentric shapes. By default, it creates circular rings or toruses. On the rings SDF, decrease the thickness to 0.03. Try adjusting the offset parameter. This parameter expands the rings outward or pulls them inward. And you can increase it as high as you want, and it will always continue to produce as many rings as are needed to fill the scene. It works on the same principle as the shift parameter on modulo 1D, where it's shifting an infinitely repeating series. Try adjusting the spacing to control how close the rings are to each other. But let's keep it at the default of 1 for now. Then try changing the shape setting to either square or diamond and see how that produces different kinds of shapes, still centered on that middle location. But for now, let's go back to the circle setting. Right now, each ring has a circular cross-section, with the radius controlled by that thickness parameter on the rings SDF. But we can also provide our own 2D SDF as a cross-section. Open the palette and create a rectangle SDF. And then connect that to the first input, the cross-section shape input on the rings SDF. Decrease the scale down to maybe 0.1. And see how we're now getting kind of a square cross-section that sweeps around the center axis. Next, we'll rotate the cross-sections so that there's an edge facing the camera instead of one of the flat faces. Create a rotate operator and insert that between the rectangle SDF and the rings SDF. Change the rotate mode to axis, and then set the rotation amount to 45. Now we've got that edge facing the camera instead of just the flat face. Then on the rectangle SDF, decrease the scale for both parts down to around 0.03. Next, we'll create and combine multiple copies of these rings arranged in a circle. Create a Radial Clone operator and insert that between the rings SDF and the renderer. Right now we aren't seeing any difference because they're all still centered on the same point in the middle. On the Radial Clone, increase the radius offset parameter to spread the copies apart. And let's leave that on a value of 1. This operator makes multiple copies of the input SDF, instead of something like modulo polar, which just reflects the shape around radially. That means that the copies can overlap, and it also means that they can be blended together in various ways. So on the Radial Clone, change the merge type from simple union to smooth union. So now we get a blending between the different copies of those rings. Decrease the merge radius down to around 0.1. Then increase the count to 6. So now we've got 6 copies of those series of rings. It's worth noting that because Radial Clone makes actual copies of its input, it multiplies the amount of work that's being done by the count. So we'll need to keep an eye on the performance when you're increasing this parameter, especially once we've set up animation at the end. Now that we've set up multiple copies of the rings, we can vary the settings across the copies. We can do that using the shift input on the rings SDF, which performs the same function as that offset parameter that we were adjusting earlier. We'll need to base the field for that input on which copy it's working with. So select the Radial Clone operator and open the Editor Tools menu with Alt-Shift-R. And then under Reference Variable, choose Normalized Index. This gives us the index of the current copy scaled to a 0 to 1 range, so that the first copy is always 0, the last copy is 1. Now we want to adapt that field so that we can easily shift it across the range of copies and have more control over how many times the value repeats in that 0 to 1 range. Create a wave field operator and connect the variable reference to its coordinate field input. Then connect the wave field to the shift input on the rings SDF. And change the wave type from sine to ramp. Try adjusting the phase parameter to shift those offset patterns across the set of copies. The result can be a little bit confusing to look at, but try paying attention to just one of the copies. For example, this one centered on this position on the left. As you adjust the phase parameter, see how you've got a series of rings coming out of that same point. And as the phase goes up, it will repeat that, and so on and so on. Then look at the copy that's centered just to the top right of that, so around here, and try adjusting the phase again, and you'll see how it's doing the same thing that the other one is, but it's delayed slightly. And as you increase this phase, you kind of shift that offsetting in a ring around the copies. On the Radial Clone, increase the count up to 12. To spread the rings out a little bit, go to our rings SDF, and we're going to increase the spacing there to 2. So now that we have a higher count, and we've separated things out a little bit, you can start to see how there's sort of this spiral pattern that emerges from the places where those rings were overlapping. Go back to the wave field and decrease the period to 0.5. So now we have 2 of those arms of that spiral overlap pattern. Next, we'll assign colors to the copies to get 2 different sections of color. Create an assign color and insert that between the rings SDF and the Radial Clone. Since we're dealing with an offset pattern that repeats twice across the copies, since we decreased that wave period to 0.5, we can use that same grouping for the colors. So the first step is to divide the copies into two groups. Create a step field operator and connect that variable reference that's getting the normalized index to its coordinate input. The step field operator takes its input and compares the value to a cutoff edge. Anything below that edge gets the low value here, and anything above it gets the high value. You can also blend, but we're not going to be using that here. What we want is to separate out two halves of the copies of the ring patterns. So change the edge parameter here to 0.5. Now we're going to connect the output of that step field to the color input on the assign color operator. Right now it's producing values of 0 and 1, which are grayscale, and one of them is too dark to see. To have the step field produce colors, we have a few options. Change the return type setting from float to vector. Now, if you adjust the different parts of those two parameters, you can get different colors there. But this isn't a great way to choose colors. So change it back to float mode, and then set the value range here back to 0 and 1. And then open the palette and create a color ramp field. And then we're going to insert that between the step field and the assign color. This will take the 0 and 1 values that the step field is producing and map them to a range of colors. So now we can use the regular color picker interface to choose the colors that we want. I'm going to use orange and blue. Next, we'll add some animation. Select the wave field that's controlling the ring offsets. Open the editor tools with Alt-Shift-R. And then under Animate with Speed, we're going to choose Phase. On the speed generator that created, decrease the speed multiplier down to around 0.1 to slow down the motion. And that's our scene. On the Radial Clone, you can try increasing the count up here to around maybe 20, depending on your GPU, to keep an eye on the frame rate and increase that kind of cautiously. And when you're doing that, I recommend typing values in there instead of dragging it with the mouse, because it will recompile the shader every time that value changes, which is going to cause Touch Designer to kind of stall a little bit when it does that. To recap, we're using the rings SDF to produce expanding concentric rings, which are then copied in a radial pattern. We're using the indices of those copies scaled to a 0 to 1 range to drive a wave field that's controlling the offset of each copy of the ring sets. Then we're using that same normalized index to separate out the copies into two groups for the ones that are below the kind of first half of that range, and then the ones that are above that first half of that range. And we're mapping that into a pair of colors and then assigning that onto the SDF. And that's it for today. Check out my Patreon to support RayTK development. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.